Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Entrancing Ergosphere by GDC. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that there are no repeats in any row. A single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell regions. We have black holes, where we need to place 9 black holes, 1 in each row, column, and box, and digits may not repeat on black holes. And for the purposes of the clues, black holes have a value of 0. So basically, a black hole is what it implies. There are no repeats on black holes, and the value of a cell that has a black hole is 0. We also need to place 9 white holes, 1 in each row, column, and box, and digits may not repeat on white holes either. So there are no repeats in any row, column, black holes, or white holes. And for the purposes of the clues, white holes double the value of a cell. And white holes and black holes can never share the same cell. So they have to be different cells in the same row, in the same column, or in the same box. And there's one of each, right? So we have black holes, white holes, and there are no repeat digits in any black hole or white holes. There's 1 per row and per column and per box for black holes and white holes, and black holes and white holes cannot be in the same cell. And here are the clues that are related to the values. We have killer cages where digits in cages cannot repeat, though values can. And values within a cage sum to the clue in the top left. A killer cage must contain an equal number of black and white holes, but that number may be 0. So in a killer cage, you are guaranteed the same amount of white holes and black holes. And but the number may be 0, right? Of course, obviously. That's the same number. It's say 0 black holes and 0 white holes, right? A killer cage must contain an equal number of black and white holes. And the values within the cage sum to the clue in the top left. So the values of these 4 digits must sum to 31. The value of these digits must sum to 34. And the values of these 3 digits must sum to 11. And you always have the same amount of white holes and black holes in the cage. So keep that in mind. We have teleporting little killers, where clues outside the grid with an arrow give the sum of digits along a diagonally traveling path starting in the cell pointed at by the arrow. This path only ends when it reaches an edge of the grid, right? So when it reaches the edge of a grid, then that's what it is. That's the total sum of all the digits, right? Now, the interesting thing is when the path enters a black hole cell, it teleports to the white hole cell with the same digit, maintaining the direction of travel of the original path, including the value of both holes in its sum. The path must visit the same number of black and white holes, but that number may be 0. Right? So this would be an example here of a path which has 0 white and black holes, right? Because it just stays on the same path. However, say we had a black hole here. Then if it goes this way, so when it enters a black hole cell, it teleports to the white hole cell. It doesn't say anything about entering white hole cells. So I assume that it can just goes past white hole cells. But say this was a black hole cell of like 3. And say there was a white hole cell here of 3. Then this path would include both of these and then continue in the same direction until it reaches the end of a grid. So then this path, this little killer clue, would be the sum of these digits, of the values of these cells, would be the sum of the values of these cells and these cells, right? Because it includes the value of both holes in its sum. And you have to have the same number, okay, that's where it is. You have to have the same number of black and white holes, but that number may be 0. So you can't, if you encounter a white hole, obviously that's going to be problematic because you didn't enter a black hole to exit out of that white hole. So you cannot actually have this crossing a white hole because you have to have the same amount of black holes and white holes on the path. And that is how teleporting little killers work. And finally, we have hole sandwiches, where clues outside the grid without arrows, so it would be this 3, this 10, and this 17, give the sum of the digits between the holes in the row or column, not including the holes. So say we had a white hole here and a black hole here. That's not obviously possible. But say we did. The sum of the we had a black hole here. The sum of the digits in between the holes must be 17 because that's a sum. That's a number that's outside the column of this column. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. We know this cage, you cannot add up to 31 just by itself. Because the max 4 digits can add up to would be 6, 7, 8, 9, since they're unique. And that's 30. So the black hole must be here. The white hole must be here. We're going to mark the black hole as the dark cell. And we're going to mark the white hole. Light is really hard to see. But it's not too bad. So we know the dark and the light hole are here. Which means these cannot be either. So we're going to mark those as blue. To add up to 34, you can't have repeats of digits, so it's the same problem here. So we need a black hole and a light hole here. A black and a white hole there. But we don't know which one's which. Okay. So to add up to 12, without a white hole or a black hole being here, is very problematic. So say this was the white hole and black hole in this cage. Then this would be 3 at most, and this would be 3 at most. It would be 3 and 2 in value. That's 5. But the black hole's max value would be 9 times 2, which is 18. So this cannot be... It has to enter a black hole here somewhere. And it could enter here, or it could... It can't see the white hole and then enter the black hole. That's going to be interesting. This is 7 at most. We have 16 here. And this is 3. 17. 10. 27. So what is 31? What are the possibilities? Obviously, you could double 9, and then you have a white hole of 1 is the minimum. So 9 doubled is what? 9 doubled is 18. Plus 8 and 7 is 33. So it could be 9 doubled here. That's interesting. Yeah, so this has to enter a black hole somewhere. So the black hole has to, well, it has to enter a black hole. What? Okay, 34. Hold up. "34 has to have 2 black holes and 2 white holes. Because if you had 2 if you had 1 black hole and 1 white hole, the 9 would be, again, you can't have repeats of digits in a cage. So that means you could have 9 doubled plus 8 and 7. Again, 9 doubled is 18 plus 8 and 7, which is 15, is 33, which is still too small. So you need to have 2 black holes and 2 white holes. So one of these is black, one of these is white, one of these is black, and one of these is white. So these are both black and white holes. These cannot be black or white holes then. And the black or white holes, I think, have to be the black hole. The white holes, obviously, sorry, the black holes can be anything. The white holes have to be 9 and 8. That's 17 times 2, which is 34. And ooh. Oh, it's the white holes that are 9 and 8. Right. Um, so the thing is, you cannot, and this 12 cannot touch this as a white hole. If it's a white hole, then it would have to be, it would connect to a black hole, and then it would be already have 16 in value or 18 in value. So this must connect to a black hole. So this is a black hole, which means you cannot have a black hole here. It's a white hole here, which means this can't be a white hole here. This is a black hole here. So this can't be black hole. This is white hole. Interesting. And because of that, if this ever were to enter this way, it would have more white holes than black holes. If it ever got to here. So it can't get to here. It can't enter a black hole here, so it must enter a black hole there. So one of these is guaranteed to be a black hole or a white hole. If we try to have the other one be here, again, it adds up to 3 between the holes. It would have to be one of these two if we go this way. And it can't be because we already have a black hole and a white hole in the box. So this must go this way. So this must be non-hole, and it's 3. And this is the other one. which means we don't have any more in the same box and the same row. So this is a black hole, this is black hole. Where's the other black hole then? It has to be here. So this is black hole then, and one of these two is light. We're not sure which. So this must be an 8-9 pair as a white hole. Then this cannot be 8 or 9 for the white hole. It can be at most 7, which is 14, and then 8 and 9. 14 plus 8 and 9 is 31. So one of these is 7, and this must be an 8-9 pair here to add up to 31. And then we don't know what the last one is. Okay. So this cannot be 7, 8, or 9. It's 1 through 6. That means we have all the 8, 9 white holes. So this, okay, so this would we know the 8, 9 white hole is one of these two. If it was 8 or 9 here, it would guarantee that it includes one of these, and then it would be 16, and then it would have to continue on its way, which is going to be greater than 1. So this cannot be 8 or 9. It could be 7. That is possible. Or it could be any of the lower ones, right? These obviously can't be 8 or 9. So these are 1 through 7 also. These can't be 8 or 9, so it's also 1 through 7. And this can't be 3 because of the 3 in the sandwich. This enters this way. If this were the black hole 7, the problem is you would have to enter the white hole 7, or exit out the white hole 7, but it includes that on the path, which is already 14. And then these are 2 digits at least, so it's 3. So exiting out the white hole would be 5 at least. If you have 5 at least, you have 10 in value. So then 10 plus 3 is definitely greater than 12. It's 13. So this can't be 5, 6, or 7. This is a black hole. This, I don't think this can be 8 or 9. Even if it's 8, you get a value of 16 here. Yeah, you get a value of 16. And then it would exit out this way. Even if it goes to another black hole, that's not good. Because you have you don't have a value here. So that's 0. This cannot be a white hole because it would enter in both. It would basically have too many white holes and not enough black holes. So this must be the black hole, which makes this not the black hole. This is the white hole. So this has to be the white hole here and is a 7. So this can't be 7 here. To add up to 31. So this is black hole here. This is white hole, so this is 1 through 6. It could be 7 and then 1, 1. That is possible. We have a white hole in one of those 3 cells. We don't know which. We have a white hole in one of those 3 cells. We don't know which. So this adds up to 17. You could have a white hole here, and that's 8, 9. That's possible. These cannot be the other white holes, because you have to have at least 2 digits in between the black hole and the white hole. You could have 4 digits in between. That's fine also. This is a black hole. Okay. So then these are not white holes because they can't be. These can't be white because you have to have the sandwich add up to 10. These can't be white holes because of the white holes in the columns. So this must be a white hole here, which makes this a black hole then, because you have to have this equal amount of white holes and black holes in the cage. Well, these are not holes here because we have the black hole and the white hole in the row, and this must be 1 through 4 here. Therefore, as a white hole, this has to be a 5, because that's the only digit as a white hole that can add up to 11. So this would be 5 here. This is 1 to add up to 11, and obviously this is a value of 0. So that means this cannot be 1 through 5. This is 6 or 7. We have 6, 7, 8, 9 here. 6, 7, 8, 9 here. 6, 7, 8, 9. This cannot be 7, 8, 9 in column 3. So this must be 6, which forces this to be 7. And then this must be 8 or 9. Therefore, it enters this black hole, it exits this white hole, and it has 2 more digits. It has 14 here, and this must be 1 and 1 to complete this path. So this is white hole, this is black hole. That eliminates black and white holes in the rest of the column and box. White hole here, white hole here, white hole one of those two. So this cannot be black or white hole here. This can't be 1. Cannot be 6. It's 2, 4, or 5. It cannot be 5 because if it were... Okay, so 5 cannot be white hole, and this can't be 1, and it can't be 3. So this is 2, 4, 6 is a white hole here. This is 1, and this is 8 or 9 in value, so it must enter a black hole. Because otherwise 8 or 9 by itself is too large. So this is the black hole in box 4. So these can't be black hole, these can't be holes, because we have the black hole and the white hole. Same with column 1. So black hole cannot be here, cannot be here or here, so this must be black hole here, which forces this to be white hole here. So we don't have any more in row 8. We have a white hole in one of those 3. Black hole cannot be here, black hole cannot be here, black hole has to be here. So none of these are holes. One of these 2 is white hole, we don't know which. One of these 3 is white hole, we don't know which. Remaining digits in box 7. We have 2, 3, 4, 5, 7. 7 and 5 can't be white holes, so this can't be 5 or 7. We already have a 7 as a black hole, so this can't be 7. Neither can this. This cell sees both 8 9s, because these have to be different digits, and a 7. So this is 1 through 6 as a black hole. This is 1. This can't be 7 because of the 7 in the column, so this is 2 through 5. This is 2, 4, 5 here, because it can't be 3. 27. If we entered 5 here, that would be... Oh, we entered another black hole. Interesting. So it could go this way. 18 enters a black hole. I don't think it could be 8 or 9 again. Actually, that's not true. It could be 8. It cannot be 9. Because it could be enter 8. A goes here. This goes 1. And then it exits out a white hole somewhere. This cannot enter an 8 or a 9. Because if it were entering 8 and 9, it guarantees that 8 or 9 white hole is there. And that's not allowed. So this must be the remaining 8 and 9s, and the black holes have to be here and here. Again, this can't be 9, because it would double, it would get the white hole 9 on its path. And that would be 18 already, and we guaranteed you have at least 1 or 2 here. So then this has to be 8. And it cannot exit this way, because if it exits this way, it collects the white hole along the way. So it has to go here, and this must connect to a 1, which has a 1 white hole somewhere. And it cannot be either of these, because it would continue on. Cannot be either of these, it must be one of these 3. So one of these 3 is a 1. This can't be 1 here then. And it can't be 1 here because of a 1 in the column, so this has to be a 1 here. Also, we can remove all 1s from dark black holes. This is 8, so therefore this must be 9 here. So again, the path goes, enters the 8, completes the 8, this is 9, this is 8, this is 9. Goes to the 1 black hole, and then exits the 1 black hole in one of these 3. Again, the one white hole cannot be here, because it would include other digits. Same with these. These would include other digits. So it's one of these 3. We're not sure which. Oh, we know none of these. So if we had a white hole here, the problem is you can't have 8 and 9 here to add up to 17. So this cannot be the white hole, which means this must be the white hole here, and this is the 1. You have to have an 8 in between here, because you can't have an 8 here. Therefore, this must be 8 with 2, 3, and 4. That's a minimum you could have, and that's what 17 adds up. That's what adds up to 17. So this must be not 2, 3, or 4. This is 5 or 6. So this has to be 2, 3, 4, 8. 2, 3, 4, or 8 in between the sandwiches. So this is now 5, 6 with 7 or 9 here. This can't be 9 because of 9 in the row. So 9 is one of those 2. What else do we have? So we've satisfied this. We haven't satisfied this or this. We've satisfied this. 8, 1, 1. We haven't satisfied this. We've satisfied the 16. We've satisfied the 3. We've satisfied the 10. And the 17 sandwiches. So it's just the teleporting little killers. We have to figure those out. Okay. There are no more black or white holes in box 9. Where's the white hole in row 1? It has to be here, which means this can't be white hole here, which means this must be white hole here. Okay. Where can this teleport out to? So this is done. We have teleporting to 8, 8 to 1, and then 1 is done. That's 18. So 8 doubled is 16, plus 1 doubled is 2, which is 16 plus 2 is 18. Sandwich works for 3 in between. This must go somewhere. So it could go here. Maybe. No, it can't. It could be. 2 doubled with 3 works. What about 12? Right, so the reason why the 1 can't be either of these is because it would continue going that way or continue going that way. Same with this, is continue going that way, continue going that way. So this had to be a 1 here. So that's correct. This way, though, you could end up here. And that seems plausible. 1 can't be here, 1 can't be either of these, so 1 has to be one of these 2 digits here. Remaining white holes. 2, 3, 4, and 6. 2, 3, 4, and 6. Remaining black holes. We have 2, 3, 4, 5, 6. Okay. But doubled. This can't be 4, 5, or 6, because 4, 5, and 6, 4 doubled is 8, 5 doubled is 10, 6 doubled is 12, and they're all larger than 7, so this is 2 or 3. Can this actually be 4 doubled? Yeah, possibly. So this cannot teleport to here because it gives you 9. This also goes this way. I think those are the only killers left, right? So this is done. So the sandwiches are done. We have 3 in between the holes here. We have 2, 3, 4, 8 between the holes here, which adds up to 17. We have 1, 2, 3, 4 between the holes here, which add up to 10. This little killer is not done. This little killer is not done. This killer is done. It teleports from the 8 to the 8, then to the 1 to the 1, and therefore has a value of 18. This little killer is done. Teleports from the 7 to the 7, which is 14 in value, plus 1 and 1 is 16. And this, so these 3 little killers are the ones that we need to distinguish. 9 cannot be here because of 9 in the row. These can't be 9 because they are black and white holes, which we already have. So 9 has to be one of these 2, which means this cannot be 9 here. So this must be 9 here. So 2 and 3, it could, okay. It cannot end up here. If it ends up here, okay, so what, yeah, where can this end up? Obviously not the 1. It can't end up here because it gets a 9 in value, which is greater than 7. It can't end up here because that would be just the value of whatever digit is there doubled, which 7 cannot be, obviously. Can't be here because it teleports to the 7, and then the 7 goes this way to the 1, which goes, this is way too large for 7. So this must teleport to here. So this is 2 or 3. If this is 3 doubled, that does not work, because if this is 3 doubled, that's plus 2, which adds up to 8, which is too large for this. So this must be 2 doubled. So this is 2 doubled, which teleports to there. Therefore, this is 2 doubled, which is 4 plus 3, adding up to 7. So this can't be 2 or 3 here. No 2 or 3 here. No 2 or 3 here. Obviously, we can't have 2s anymore in the black holes and the white holes. We have a 4-5 pair in the white holes. Therefore, this must be 3. We have a 4-5 pair in the black hole, so this can't be 5. This is 6, which eliminates 6 in the rest of the region. This can't be 6. This can't be 2. So this is 3, 4 as a white hole. This can't be 2 as a white hole. So this is entering in 3. And it cannot be this one, obviously. If it goes here, this is just too large. It goes to 7, which includes 7 doubled, which is 14, which is too large. So this must exit out this way. This is 3, then this is 4, and this is 6. This can't be 2 or 3, because of 2 or 3 in the row and column. Can't be 4, so this is 5, which forces this to be 4. This can't be 4 or 5, it's 2. Okay. So this must add up to 6. Right? Because you have enter in 3 doubled, that's 6, plus 12 minus 6 is 6. So it could be 1, 5 if this is 1 and that's 5. It could be 2, 4 if this is 4 and that's 2. So those are the possibilities for this little killer. This can't be 4, so it has to be the 5 black hole. because we have a 4 already here. That eliminates 5 from the rest of the box. This is 4, 7 as a pair. 2 eliminates 2 here. 4 eliminates 4 here, and 4 here. The 4 is interesting. Okay, so we have 8 in value plus minimum. What's the maximum here? 8 in value plus 4 plus 7 and 8, which is 15. 15 plus 4. 15 plus 4 is 19. Huh. Okay. Not the most helpful. Okay, so 9 is one of those two. 9 is one of those two. 9's here. 9 has to be one of these two here. Let's look at 1s. Where's 1 in row 6? Can't be here because 1's in the boxes. Can't be here because of 1 in the column and the white hole. So this must be 1 here. Where is 1 in box 3? Can't be here, here, because 1's in the row and the columns. It can't be here because 1 in the column, so it must be here. So this is 1, which eliminates 1 here. So this is 1 and 5, adding up to 6, which added with 3 doubled is 6. That adds up to 12. Okay, so we have all the 1s now. 2s, we don't really have much information. 3s, we know this one of these two is a 3. 4, where's 4 in column 2? Cannot be here because 4 in the box. Can't be here because of the 4, 7 pair in the box. Can't be here because 4 in the row, so it has to be here. So this is 4. Remaining digits in column 2 are 6, 7, 8, 9. This can't be 7 or 9. This can't be 6 or 8, so this becomes a 7, 9 pair here. 9 can't be here, so this is 7. This is 9, which makes this 8, that 9. This has to be 6 then. That leaves this digit as a 5. So this can no longer be 5 here. This can't be 5 or 6 because of 5 in the row and the 6 in the column. So this is 7. This can't be 7 or 6. This is 5. We have a 3-8 pair remaining in row 1, or column 1. So this can't be 8 because of 8 in the row. So this is 3. This is 8. That eliminates 8 from being here. So this is 1 now. 1 plus 8 is 9. The remaining 3 digits then must add up to 27 minus 9, which is 18. If this is 2, this would guarantee this would have to be 16, and this 9 would have to be there, but we obviously can't have a 9 there. 9 has to be one of these two. So this cannot be 2 here. It's 3 or 4. One, 4, 4, 3, whatever. Let's see. Is there guaranteed to be an 8 here? Can we not have an 8? The minimum without an 8 would be 7 and... Sorry, the maximum without an 8 would be 7 and 6, which is 13. 13 plus 4 is 17. 17 plus 8 is 25, plus 1 is 26. So no, you have to have an 8 here. And the 8 cannot be here because of the 8 in the column. So 8 has to be here. So this could be 6 or 7. Obviously, if it's 6, this is 4. So this adds up to 18. If this is 7, this is 3. So that works either way. And the rest, we probably have to just do normal Sudoku. Row 1. We have 4 and 6 as a pair. Okay. Row 2. We have 2, 7, 8 as a pair. Well, this can't be 7 or 8, so this must be 2, which forces this to be a 7, 8 pair here. This can't be 8 because of 8 in the column, so this is 7, which makes this 8. 7 eliminates 7 here, so this is 6. This adds up to 14. 14 plus 8 is 22, plus 1 is 23. 27 minus 23 is 4. So this is 4, which eliminates 4 here and 4 here. 6 eliminates 6 here, so this is 4. And 6, the remaining digit in box 2, is a 2. Okay. Remaining digits in row 3. We have 4 and 6 again, and this can't be 4 because of 4 in the column, so this is 6, this is 4. Okay, we're looking for a decent amount of set digits. There aren't that many, interestingly enough. Okay, remaining digits in column 6. Okay, actually we have a 3, 8, 3, 8 pair in column 7. That eliminates 3 and 8 in the rest of the column, so this is 2. Where is the 2 then in row 4? Can't be here because of 2 in the box. These are filled out digits, and they can't be here because of 2 in the column. So it has to be 2 here, which eliminates 2 here. So this is 3. This is 2. Okay. We have 8 2s. We know where the last 2 has to be. It has to be here. We should have 8 and 9 1s. We do. You have 8 2s. 1, 2, 3, 4, 5, 6, 7, 8, 9 now. 3. Huh. Okay, that's not enough information. 4. Probably not enough information. 5. We're very restricted on 5s. Particularly in box 5. Cannot be here, or here. So it has to be here, which means this is 5. This can't be 5 anymore. This is 9. Okay. We're not that restricted in 5s for the rest. 6. Where's 6 in row 5? Can't be here, can't be here. It must be here. Where's... We should have 8 6s. 1, 2, 3, 4, 5, 6, 7, 8. We know where the last 6 has to be. It has to be here, which eliminates the possibility for 9 to be there, so this must be 9 there. That should give us 8 9s. We have 1, 2, 3, 4, 5, 6, 7, 8 9s. And the 9th 9 has to be here. Okay. 7s. It's kind of... Okay, in box 6, we know where the 7 has to be. Can't be here, can't be here, so it must be here. We also know where the 3 is in row 5. It has to be here. That means we know where this 3 eliminates 3 here, so this is 8 and 3. We know what the last digit is in column 8. It's 5. Last digit in box 9 is an 8. 8 eliminates, so that means the last digit in column 9 is a 5. That leaves this digit as a 4. We have 4 and 7 here. And 4 and 7 here. Remaining digits in column 4 are what? 3 and 7. 3 can't be here, so this is 7. This is 3, which makes this 7. That leaves this as a 4, which means this can't be 4. That's 7 and 4 here. And that's the solution. Pretty cool, actually. I like the whole teleporting through the black holes and the white holes. It was very interesting. You're definitely very restricted for the cages, which is good, I guess. I mean, it does limit things a lot about where things can be. So, I guess that's helpful. Yeah. Overall, very cool. Very nice little puzzle. I like the teleporting and the black and the white holes, entering and exiting black holes and white holes. I think it would have been a little bit more interesting if you could enter white holes too, but yeah, that works too. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.